Hello, everyone. Welcome to Google I/O. My name is Luis Hector Chavez, and I'm one of the engineers in the Chrome OS team. Maybe you saw today's earlier announcement that we're bringing Android apps to Chromebooks. Woo! Yay! So I'm super excited to be here because I can finally tell you guys what we've been working on for the last few months. So it's not a secret anymore. All right, so first of all, let's talk a little bit about why we're doing this and why it should be interesting to you. First of all, Chrome OS is a growing platform. While overall PC shipments are declining, Chrome OS continues to grow. In fact, last year we had 33% year-over-year growth. The numbers get even better in certain segments. For instance, Chromebooks are the #1 device in K-12 EDU in the US. There are millions of active users with more than 50 different devices from 13 OEMs in 44 countries. And we've got lots of amazing Chromebooks coming out. OK, so we have a large growing platform with a large number of potentially new users. This is where you Android developers come into the picture. All Android developers want more users. All Chromebook users want more apps. But they just don't want any app. They want the apps they know and love. So we believe that bringing Android apps to Chromebooks provides a middle ground that helps both groups of people. OK, if a developer wanted to bring their application on Chromebooks, what are their options? Let's start with a non-solution. You can write a Chrome OS app. This is essentially writing your application twice. This required you to learn a new platform, which might yield an application that looks more native. But it's a lot of work. It's a lot of upkeep, and you need to maintain 2 potentially separate code bases. So it's not an option for most people. Another option was to build an HTML5 application. This might yield an application that looks and feels native in Chrome OS, but you would need an Android HTML wrapper, which doesn't look super native. It also doesn't take a lot of advantage of the Android platform. So it's still not a great option. Another option was App Runtime for Chrome. We in the Chrome OS team released this 2 years ago in 2014 as a way to run Android applications in Chromebooks. We were running full Android instances in a native client sandbox. Unfortunately, it had some challenges for developers. Access to some of the system resources was restricted due to the advanced nature of native client sandbox. For instance, we had to do full file system emulation because it was not available to us. And some apps didn't work great with this. Native Client also had a single process execution model, which caused some applications to not work great, especially the Google Play Store. Finally, some of the features that are critical for developers, like in-app payments, required extra work on your behalf. Having said all that, we still believe that getting Android applications running as fully integrated native Chrome OS apps was the right idea. So we made a lot of improvements, and we're building a whole new platform to run Android apps on Chromebooks. All right, so many of you might have missed today's earlier demo. So I'm going to give a shorter one right now. OK, so first of all, this is standard Chrome OS desktop. But you can see we have the Play Store now. Yay. And of course, I don't have internet, so there's no Play Store. But fortunately, I already installed a few apps, like Gmail. Ta-da. So one of the things we're doing here is that we do have multi-window support. And not only that, we can also change the size of the window. We can also maximize it, stuff like that. Neat things. We also support integration with some of Chrome OS's native notifications, for instance. Hello, world. And of course, as I mentioned before, I don't have internet, so let's skip that. Oh, there you go. So as we see, we can have offline access in Android apps now. Right, let's go back to the slides. OK, we already saw what it looks like. So let's talk a little bit more about how it's implemented. First of all, we're not using a native client anymore. We're using a brand new sandboxing mechanism. It uses existing Linux namespaces to isolate Android and Chrome OS. These are already used in Chrome OS and in some of our cloud offerings. We're using mount, process, user, network, and IPC namespaces. The Chrome OS security team also developed new features for this. Since Android is running directly on top of the Linux kernel, this increased the attack surface a little bit more than we were comfortable with. So the Chrome OS security team developed a new way to add alternate syscall tables. This is more efficient and configurable than existing system call filtering techniques like secombpf, which, by the way, the Chrome OS team also developed. Having both Android and Chrome OS do their own compositing would make everything slower. So we have a shared compositing model where there's only one overall compositor. This makes things a lot faster and more responsive. Finally, since we know that a lot of Android developers target NDK for ARM only, we're providing just-in-time binary translation so that their already existing ARM applications can run on x86 devices, like the Google Chromebook Pixel, with no work required on your part. So this new approach still maintains a high level of security in both operating systems. You get to keep all of Chrome OS's security features, like verified boot, user data encryption, continuous updates. And Android still has SELinux running. There are no virtual machines or emulation going on, so you get full native performance. And finally, since we're running the whole Android system, you get to run all of Android Marshmallow within Chrome OS. This includes the Google Play Store. So something that we learned with App Runtime for Chrome is that integration matters. The more integrated the apps are with the rest of the operating system, the better they look and feel. So we only grant direct hardware access to Android in very few occasions. The rest of the time, the hardware is still managed by Chrome OS. But still, we added a lot of integration points so that Android developers can still call the same APIs, and those APIs underneath will make calls to Chrome OS. This allows both operating systems to share the same view of the system instead of having split views. OK, so what does it all translate into, and how does it impact your applications? Because we're running a full Android system, it means that most applications can be run in Chrome OS without any code changes at all. Of course, since this is a new platform, you might want to still make some optimizations and some little tweaks. But your app works like a Chrome OS app. Most of the things you expect the Android system to do will be now provided by Chrome OS, instead of being constrained to a little window. Every task runs in its own window. You get Android notifications together with Chrome OSs. There's just one app launcher and shelf. Signing information will be shared between operating systems, so you don't have to log in twice. You're also able to share files in the downloads folder as well. Hardware is also integrated, so you still get connectivity through Wi-Fi and Bluetooth. Camera, microphone, audio, and video still work. All of Chrome OS's input mechanisms are still plumbed through your application. So keyboard and trackpad events will be delivered to your application, and also touch events if the Chromebook supports it. Meanwhile, your application still behaves like an Android application. Since we're running a full Android stack, the whole Marshmallow API is available to you. This includes Google Play services, so things like in-app payments will be available in consumer Chromebooks. We're also not adding any new APIs, so there's nothing for you to learn this time. All system services are running, and all the interactions between the system services and your application are exactly like you would expect. This includes things like the application lifecycle events. Finally, the hardware is abstracted so that you don't need to worry about anything. I want to be clear. While apps can be run in Chrome OS, we still require Chrome OS users to opt in to use this feature. We understand that there are some scenarios in which people don't want to enable this just yet. We're also providing enterprise and education users with additional policies that can enforce if and which applications can run on the devices they manage. All right, when is this going to be available? For you developers, we're enabling this feature on Chrome OS 53. This should be available in the dev channel in June. M53 should be generally available for all users in the stable channel in September. So you still have some time to prepare. We'll start by supporting 3 devices, the Asus 10-inch Flip, the Acer Chromebook R11, and the Chromebook Pixel 2015. We'll gradually bring support to more devices in later milestones, so stay tuned. And that's the URL where you can check which devices will be getting support on which releases. So stay tuned. OK. It's great that most applications will work out of the box without any code changes. But let's take a look at the best practices you can take into account so your application works even better on Chromebooks. There's a wide variety of Chromebook form factors. All of them have a physical keyboard and trackpad. Most of the devices we'll be rolling out support to have a touchscreen as well. Some of them are even convertible, so they can switch between a laptop and a tablet form factor. While we were testing applications, most of them we found out that they already work pretty well with keyboard and mouse. Still, not all of them did. So it's better that you developers take into account testing with a keyboard and mouse. Also, since there's essentially new hardware available to you, might as well make the best of it. So productivity applications can have things like hotkey support. That'll make users even more productive. Some games even lend themselves to be controlled using a keyboard and mouse. Sorry. OK, now for the important coding part. By default, all Android applications set the touchscreen hardware feature to be required. Now, I mentioned before that not all Chromebooks will provide touchscreen. So it's very important that on your Android manifest.xml, you set the android.hardware.touchscreen feature to be not required. This will allow your application to appear in the Play Store for all Chromebooks, instead of just for the Chromebooks that support touch. If you go out of this presentation with just one thing in mind, let it be this. All right, best practices for multi-windows. On laptops, everybody uses multiple windows for productivity, given that there are more pixels available on the screen. Now, I did mention a couple of times before that we're supporting Marshmallow API. And Marshmallow doesn't have the APIs for multi-window. I also mentioned that we are not adding any new APIs. So how does it work? In order to minimize the amount of work needed for everybody, we're only supporting a few layouts that your application already most likely supports. First of all, we have landscape. This is the default layout. This uses a Nexus 9 aspect ratio and device density. We also support portrait, which runs just like a Nexus 5. We also have maximized windows, which take up all available pixels on the screen. Finally, for convertibles, we have Touch Me mode, which is more or less the same as maximized, but hides the window decorations and the shelf at the bottom. So it's similar to Android's immersive mode. We added some window controls to toggle between all the available layouts. This allows both users and developers to choose the right balance of information density in the sizes and layouts the applications were originally designed for. Now, some things you need to be aware of. Similar to End's multi-window implementation, we're not changing the application lifecycle model. Exactly one application will be on the on-resume state, and this is the window that's currently focused. All the rest of the windows and applications are in the on-pause state. Also, the out-of-memory killer is integrated with the rest of the operating system, and it takes the Z order of the windows into account when calculating the final score. So applications that have been least recently used will be killed first. Okay, so since changing orientation also changes the physical size of your window or of the device, you need to declare the correct Android screen orientation so that it only uses the ones it supports. Now, it's also important that you go read this document, the handle runtime changes in the official Android documentation. There will be some things that you don't expect to change whenever changing orientation. For instance, the screen width and height will change in ways you don't necessarily expect, because on normal devices, they only flip between them. And here, you can have totally different values. Also, the density DPI setting can change when you switch orientation. Also, very important, make sure you invalidate any cache resources. Since once you change orientation, you're effectively changing device, you need to make sure that you load the correct resources after the orientation has changed. Now, these two things are still important for Android N, so might as well do them right now. Also, use the correct task affinities. As I showed you in the demo, it's possible for a task to launch another activity in a new task. This will render a new window. But if your intention was to have a model window, you should put that activity in the same task. Otherwise, you might get into application flows that you weren't expecting. Finally, respect the on-pause state. While your application might be paused, it's still visible. So make sure you're not doing any rendering, because that might look awkward for the user. And it will also consume a lot of battery. Using backup and restore effectively is also very important. One of the best features about Chromebooks is that users can just throw out their machines, get a new one, log in, and all their applications and settings will be there. So it's not totally required to support backup and restore, but it's a very good idea, and users will love it. Make sure you read the official documentation of backup and restore. There are also some scenarios in which Chromebook users, Chromebooks can be shared amongst a large number of users. For instance, in education, students don't get their own personal Chromebooks. They are shared between students. So if you're writing applications for education purposes, make sure to take this scenario into account and be mindful of the local storage you use. Now, in general, Chromebooks support less amount of sensors compared to mobile devices. For instance, most Android developers are used to having a GPS device to get accurate location information. Chromebooks don't have a GPS device, but they can still get coarse location information through the use of Wi-Fi. This might be enough to get the best restaurants around you, but it might not be enough to get just grab a Chromebook, put it in your car, and expect to have turn-by-turn navigation. So the recommendation is to make sure you don't require hardware that might not be available. Of course, if your application does require some piece of hardware that's not available on Chromebooks, we'll respect your decision and not show that application on the Play Store for Chromebooks. There are some other software features that are not going to be supported in Chrome OS. Since we want users to have the full Chrome OS experience, applications that customize some parts of the UI will not be available. Applications that provide custom input methods, app widgets, live wallpapers, or home screens won't be supported. Also, Chrome OS is going to be the device manager for Android. So applications that declare themselves to be device admins or manage users also won't be supported. So we will be shipping initially with Android Marshmallow, but it's still a good idea to focus some efforts in upgrading to N eventually, because it will bring a lot of features that will improve desktop productivity to users. For instance, you will have the ability to fully resize activities instead of being constrained to one of the 4 layouts we support right now. You'll also be able to use drag and drop between applications. And there's going to be a new mouse cursor API available. So in order to learn more about N, you can watch these two presentations that aired today here in I/O, the What's New in Android and multi-window mode. Also, you can consult the official Android N developer preview documentation. OK, if you have any more questions about this, you can consult the official documentation for Android apps for Chromebooks. You can also ask questions in Stack Overflow or post questions on the Android G+ community. Now, before I go, a lot of you tried to get to today's earlier announcement, but couldn't get to it. So we're going to redo the demo that we gave earlier today. So here's Katie that will present to you the earlier demo.
All right. All right. Thanks a lot, Louis.
Can we switch to the demo?
There we go. All right, very good. So apologies this morning that we were a little short on space. So we thought with these extra few minutes, we could go back through our demo flow. So unfortunately, it'll be a mildly different second rendition, hopefully a little bit better. But here we've got a Pixel 2. It looks like a regular Chromebook. It's got our Chrome browser here, but you obviously now have the Play Store on the shelf here. So we'll go ahead and launch that. So here we can actually browse through our apps. Looks like we've got just like the regular Play Store. So let's go ahead and install something. So I think we decided Bejeweled was a pretty good game. Let's search for that, and we'll go ahead and install. Oh, and look at that. Coincidentally, apparently, Can's wife is asking me to make a poster for Can's child's birthday party. So being a good employee, let's go ahead and reply to Can's wife. I'd love to. The great thing about the way we've integrated Android is we get the nice inline reply that you'd expect on your tablets and phones. So I'll go ahead and send that off now. Great. So let's go ahead and do that. I've already installed Photoshop Mix from the Play Store. So I'll go ahead and launch that now. So that's actually a picture of Can's kid, I think, feeding a pen to Piglet. Odd. Anyway, I've been told that it would be more appropriate to put ice cream there instead. So we'll go ahead and try to find some ice cream here. So luckily from Adobe Stock, they've got some great photos of ice cream. It's actually very bizarre, like half Neapolitan ice cream with some pistachio. But that looks kind of big. So why don't we go ahead, we can use the touch screen, just like we'd expect. We go ahead and shrink our ice cream going down. That's a little bit better than a pen, I suppose. One of the problems here, though, is obviously now our cone is kind of over her hand. So we'll go ahead and cut out that. We can zoom in. We can zoom in a little bit more. We can go ahead again, use the touch screen. Oh, that was a chunk out we didn't want. We'll go ahead and revert that. And there we go. We'll go ahead and, well, there we go. That photoshopping live, not my finest work. Probably. Probably come up in my next performance review. But OK, let's go ahead and save that anyway. All right, we're saving that. That looks great. So I've been told that he wants a poster. So let's go ahead and open up a Word for that. What's really nice about this is I can now just go, and I've got kind of regular Word here, throw in some photos for Leanne's birthday party. There we go. That looks pretty good. So I want to now get this back to Can's wife. So let's go ahead and we can click that we want to share this as an attachment. Go ahead, open up the Gmail. We hear that's a pretty good product. And go ahead and send this off to Nan. That looks great. Let's go ahead and send that off. Oh, what do you know? Just coincidentally, someone is attacking me on Clash of Clans. So again, with how we've integrated the Android framework, chat heads just work. This is Shahid right here. we'll go ahead. We better go check out our village. So Clash of Clans. We go ahead and close Photoshop. We don't need that anymore. Sorry. Go ahead, get Clash of Clans rolling for us. Oh dear. You guys have never ever seen a demo not work on stage. All right. We'll go ahead. We actually have a slight known bug here. Any case, though, we'll go ahead and continue on from that. Apologies there. Another great game, other than Clash of Clans, which I also like a lot, is Galaxy on Fire. Here we're able to get the nice use of the desktop GPU. Everything's super smooth. I don't know if it looks super nauseating to y'all in the audience, but anyway, very good performance here as well. With that, I can also do in-app purchase as well. So we can go direct, we can go to buy an add-on, and go ahead and click buy. And now this will be available on my phone, payment successful, great, as well as my tablet as well. So again, this was just a quick view of what we also showed this morning. We are, of course, very excited to be working with all of you to bring your apps to Chromebook. So thank you very much.
All right, that's it from both of us. Enjoy the rest of the show. If you have any questions, ask them on the Spaces app, or we'll be hanging around down the stage. Thank you. Bye.